Hello and welcome to the Section 2.2 lecture today for Algebra 1 Part 1. Today we're going to start talking about a little bit more in depth, our algebraic expression conversation, kind of getting us into the meat and potatoes of our Algebra 1 material. So to start off, we're going to look at expressions and more specifically combining like terms. Another phrase for that might be to think about simplifying expressions. Okay, that's another idea when it comes to combining like terms. Let's see. So for the definitions we have, the first thing, an expression is a mathematical statement. Okay, now we kind of equate this to learning English a little bit. Something that's comparable in English would be something like I ran. In the sense that I went for a run. It doesn't say where you're going. It doesn't say why. It has some pieces of a sentence, but it's not quite a full sentence in the sense of, subject and content, that kind of thing. So it's kind of weird to talk about mathematical expressions, but it's going to be worthwhile, and we'll get to why it's worthwhile in a future talk. So the next definition that we have is a variable, and this is just an unknown quantity. So an unknown quantity. And then a coefficient is a number multiplied by a variable. Okay. And then a term, one thing that's kind of missing here that I would say would be exponent, but we've talked about exponents in the past, just like we've talked about variables in the past. A term is a coefficient. Actually, I'm going to back up a little bit. I'm going to say a sine coefficient variable and exponent combination. All right, so it's all those things wrapped into one is what we consider a term to be. And then an expression is going to end up being a collection of terms, okay? So it might almost make more sense to have expression towards the end, but the way that we really want to think about an expression is a collection of terms. And then a like term, or like terms, I might say, is something that has two terms. Let's phrase it that way. Two terms with the same variable and exponent combination. And we'll get to why that's important as we go through this. So the next part we want to do is we want to look at all the different terms in the following expressions. I think this is very valuable when it comes to combining like terms, is just to talk about what terms are. So again, it's sine, coefficient, variable, and exponent. All those things together sort of package up a term. And so the way I think about them is I think about squaring my terms. And when I do this, what I really like to do with this is to think of these as individual blocks or building blocks of these expressions. All right, so we've got three terms in this first one. We've got 5x, positive 2y, and negative 15z. The reason I like packaging these up this way is that I can move all of these around. Now we've heard of, probably way back when, we've heard of the commutative property. And that's an important property that we're gonna kind of use without really stating that we're using it. And there was always a concern about the commutative property, and we've kind of talked about this when we dealt with numbers and adding and subtracting numbers, is that subtraction doesn't work with the commutative property. You can't move things around subtraction. If I just look at this and I say what it says, just to actually write it down, to say that I cannot do this. This is not allowed, right? That's not the same thing. Those two things are not equal. But when I think of them as these blocked out pieces, I can switch these two pieces around. Okay, but this is why I say that a term involves the sign. The sign is also involved. So I can take this 15z and write it next, but I have to write it as a negative 15z. Or, and notice I said negative, I didn't say minus. You might battle me on that, that's okay. Yes, it's minus 15z, but me saying negative 15z really means that I've turned this into addition of a negative 15z. And that's all I've done in order to commute those two, in order to switch places with those two correctly. Okay? And so that's legal. That is saying the same thing. Okay, but just doing it the way I had it before with the 2y, or with the 15z minus 2y, that wouldn't be okay. So it is helpful to identify all of your different terms, right? So I have this 2x squared, I have a plus 15x, I have a minus 3x, and I have a plus 5. Okay, this one just happens to not have a variable and an exponent, but that's okay. Now I know that looks good with all the different colors, but that's a little more work than I need to do, because it's also something that you can't do as you're writing this with just a pencil. Okay, now if you want to add color to yours, feel free, right? It helps make a little more sense of what's going on. But again, I think of all those different pieces: sign, coefficient, variable, exponent. Sign, coefficient, variable, exponent. Sign, coefficient, it's kind of there, it's kind of not. Variable and exponent, right? Those are all different pieces of these expressions, right? And that's all these are. These are mathematical statements, because there is no equal sign, so it wouldn't be a complete sentence. But they're still statements, and they're still valid statements that we can do something with, right? We would want to simplify them if possible. Okay, let's look at how we might do that. When we want to combine like terms, okay, what that means, or if it said to simplify the expression, yeah, I want to make sure I spell it right. Simplify the expression. What that really means, without, I guess, saying exactly what it says, it really means to gather all like terms and write them as one term. Because it would simplify that said expression. Like if I look at this one here, this one's a great starter example. If I take this problem that says 2x squared plus 15x minus 3x and plus 5, as we noted before, I have these two terms here where I have a positive 15x and a negative 3x. And then I have these other ones where I have a 2x squared, and then I just have a plus 5. These two do not have any common terms, looking at this one and this one. Okay, those two do not have any like terms. But these two, on the other hand, are the same. They're both what we consider to be x terms. All they have are x's. So then what I do is I want to add and subtract the coefficients of those variables, of those terms, right? So if you want to think of it, and you probably heard it with this before, I've got 2 apples, 15 oranges, negative 3 oranges, and 5 bananas. That's the way we consider combining like terms. How many oranges do I have? Trying to think back to what I said, right? I can't really do anything with this because it's by itself, and I can't really do anything with this. But these two I can combine. I can figure out how many I have total and write those two terms as one to make this a simpler expression, right? So positive 15 and negative 3 is going to turn into positive 12, and that's how many x's I have. You'll hear me ask the question often, if we have 15x and we take away 3 of those x's, how many x's do we have? Okay, the one thing that you want to avoid is the thought of this. This is one major pitfall that a lot of students would fall into. They might see something like 15x minus x, and they would say, well, that's 15. That's incorrect, because this is 15 x's. And if it helps you, write this as minus 1x. And then you want to think about, so this is not equal to 15, it's in fact equal to 14x. That would be the right combination there. Okay, but let's move on from there and see what else we have. So we've got some examples. Okay, and the first thing that I do in a lot of these is I go through and I use different styles of underlining, and I'll leave it up to you on how you want to underline them. But just to go through once and kind of pick out all my common terms, right? So I'm looking at this first one, and I notice that I have x's and I have numbers, right? And so maybe I do my x's with a little squiggly line and my numbers with just straight underlines. I want to combine every term that has the same style of underlining. I only have one squiggly underline, so that one's going to stay by itself. Straight underlines, I have 2 of those, and I have I have positive 7 and positive 8. And I want to think about just combining those together. I want to get you away from the idea that it's positive 7 plus 8. I mean, you can use that, but I just think it's quicker if you just think about what happens when I mash those together. What do I end up with, right? I would end up with 15. Of course, I would come up with the same answer either way, but that way just makes it actually a little bit quicker. Okay, I've got a number, I've got a variable term, and I've got a number term. Notice that I'm including the sign in front of each term, except for this one, but this one's kind of an unwritten positive, right? So I've got one squiggle underline, and I've got 2 straight underlines. I've got a positive 3 and a negative 10. What do I get when I slam those together? Okay, I get negative 7. And if you're ever unsure, grab a calculator and check it. It does end up being 3 minus 10. But again, I think of it as it's a positive 3 and a negative 10. When I mash those together, what comes out? Okay? I think that that's beneficial, and I think that might speed you up a little bit. Next one, I've got an x term here and an x term here, and I have a number term here and a number term here. So I have two different things that I have to combine. Sorry that you can't see that. No, you kind of can. But yeah, that just ends in minus 3x. My face cam's over it just a little bit. But so the complicated part of this would be moving these things around, and we don't typically write this, but we could rewrite this as 4x minus 3x and plus 5 plus 1. And even more so, we can then undistribute the x. I'm going to use that term kind of generally. I'm going to undistribute that x and also look at the plus 5 plus 1. And that's the technical way to do it. I don't like that. I like thinking I have 4 x's and I have negative 3 x's. And what happens when I mash those together? I'm going to get 1x. And you can either write x or 1x. I don't really care. If it helps you to write 1x, then do that. And then the plus 5 plus 1, that's going to end up at plus 6. And that's our final answer. But I would accept x plus 6 also. Okay, that's probably more common of an answer than this one. Okay, let's look at the next one. So I have negative 14. Maybe I use a straight underline for that. I have a negative 12n. I'll use a squiggly underline there. I have another number, so that's a straight underline, and another variable. And that's pretty straightforward. Okay. Variable-wise, I have negative 12 and negative 9, and I'm going to slam those together, and I'm going to come up with negative 21. Number-wise, negative 14 and positive 1, slam those together, and we get a negative 13. And that problem's done. Okay, next one here, and I think these are our last two. Yeah, they are. That's pretty good. I notice I've got a lot more happening. I have an x squared, I have an x squared number, and x. So I'll actually need 3 different styles of underlining because x squareds are different than x's. I cannot combine those. So maybe we use kind of a square bracket underline for my x squareds, squiggly for my x's, square bracket, straight underline, squiggly there. More often than not, we do like to write our expressions with our highest exponent first, and then our next highest exponent, all the way until we get to our x term, which is technically, we haven't talked about this, but this 3x is technically 3x to the first power. It's like multiplication in that if there's nothing written out there, the exponent is a 1. And then we like to end with our numbers. So I'm going to deal with the x squareds first. As far as x squareds go, I have 15 and negative 8. 15, negative 8, slam those together, we get 7x squareds. Now, x term wise, I have 10 and negative 3. That's going to give me a 7x. And then number wise, I just have a 5. And there we go. That's all there is to it. Last one here. Oh boy, I've got x squareds, I've got y squareds, I've got x's, and numbers. So I've got a lot going on. X squareds and y squareds don't cancel. I'll use the same kind of square bracket for my x squareds, maybe a u bracket for my y squared, squiggly for my x squared, for my x. This is another x squared, so it's going to get my square bracket, and then my number will get the straight line. Okay. This was the number one thing that helped me, and this is why I teach this way. Now I'm just looking at my common symbols rather than trying to look through there, and that way I could also kind of cross things off as I go if I wanted to, and then I would know that I've dealt with those. First, my x squareds, I've got a negative 5 and a positive 5. Well, negative 5 plus 5 is 0, so those actually just cancel out. Okay. My y squareds, I have 3 of those, and that's all I have. My x term, and so maybe I just cancel that out, like I've dealt with that. My x term, I have 5 of those, and that's the only one I have. Yep, I've dealt with that. And my number term, I have -3. And I've dealt with that. Then I can go through and just verify, yep, I dealt with that, dealt with that. I dealt with all those, so I'm good to go. That's all that's left as my answer. Okay? So thanks for watching. I hope you put any questions you have over on the left-hand side. Make sure you ask those right when you get to class, and we'll try to go over those together. Otherwise, I hope you have a great day, and we will see you in class.